All right, here's a video for 2-4, multi-step and solving for the whole triangle. So for this multi-step trig problem, we're solving for x, and we're kind of given two triangles. So here's what we're going to do. We first need to solve for this shared side here, which is y, because we can't use this triangle and this angle. We know this is a reference angle. There's not enough information to solve for x. We need at least one more side. So what we're going to do is we're going to solve for this shared side right here. And once we have that, we're going to use that information to solve for x. So looking at this bottom triangle, 28 is my reference angle, 9 is my adjacent, y is my hypotenuse. So AH means it's going to be cosine. So cosine of your reference angle equals your adjacent over your hypotenuse. And then we're going to cross multiply. So we get y times cosine of 28 equals 9 times 1, which is 9. And divide both sides by cosine 28. So putting that in our calculator, we have 9 divided by cosine 28, we get 10.19. So now that we have this side, now we can use 63 as our reference angle, and we can label our sides. Well, x is our hypotenuse. This is now my opposite side, so OH tells me I'm going to use sine. And it's going to be 10.19 over x. So same thing, cross multiply. We get x times sine of 63 equals 10 times 1, or 10.19 times 1. And then divide both sides by sine of 63. So again, using our calculator, 10.19 divided by sine 63, you get 11.44. And in this case, since there are units, we're going to go ahead and put units. So 11.44 centimeters. All right, so let's take a look at this example. So still a two-step problem, but in this case, we're solving for an angle. But we can't do anything with this triangle yet because there's not enough information. All we have is one side. So just like the previous problem, we need to solve for this shared side, so we can call it y. So looking at this problem, we might notice that, hey, wait, we don't have any angle measurements, so we can't use trig to solve for this third side. So what we need to do is we need to remember some other things that we've learned to solve for missing sides. And remember, when you're given a right triangle, you can also use Pythagorean theorem to solve for a third side. So in this case, we're going to use Pythagorean theorem. This is my hypotenuse. So it's going to be 11 squared plus y squared is equal to 13 squared. 11 squared is 121. 13 squared is 169. Subtract 121 from both sides. So 169 minus 121, we get 48. And then we're going to take the square root of both sides. And we are just going to get the approximate answer for this one. So square root of 48, 6.93. So this side right here is 6.93. Okay, so now that we have that, now we need to see if we can solve for the angle. Well, here's our other problem. We haven't learned how to solve for missing angles using trig, right? Because we can use Pythagorean theorem, that will solve for the third side. However, if we were to use trig, well, let's see, solving for this angle, this is my opposite side and this is my adjacent. I could use tangent, and we can set it up like we normally would. However, we haven't dealt with this where we're taking the tangent of a variable. So that's what we're going to learn how to do next. And we'll come back to this problem. Okay, so in order to solve for angles in right triangles, we can use what's called the inverse trig function. So in terms of how we set up these problems, it's the same way. We're still going to circle our reference angle, and we're going to label our sides. This is O and this is H. This is O and this is H. And we're still going to set it up the same way. So this is going to be sine x equals opposite over hypotenuse. And same thing here, sine x equals opposite over hypotenuse. Okay, however, what we're not going to do is we're not going to cross multiply, because cross multiplying isn't going to get x by itself. In order to get x by itself, we have to get rid of the sign. Well, just like any function has an inverse or an opposite, like adding and subtracting are opposite, multiplying and dividing is opposite, square rooting and squaring is opposite, the opposite of sine is inverse sine. So sine -1. So what we're going to do to get rid of x is we're going to take the inverse sine of both sides, because whatever we do to one side, we have to do to the other to keep it balanced. Taking the inverse sine gets rid of the sign and it leaves you with just x by itself. So then what we're left with is inverse sine 12/17. Okay, we can do the same thing here. You don't necessarily have to show the step of taking it both sides. If you want, you can go straight to this step, inverse sine. And we do this only when we're solving for angles, 3/7. So to actually get the answer, we just have to put that in our calculator. So using the Desmos calculator, the way that you're going to do it is you're going to hit the function button, and that pops up the inverse trig functions. So inverse sine, and then it's going to be 12/17. We're going to get 44.90 degrees. Okay, the second one, again, we're using inverse sine. So we hit inverse sine, 3 divided by 7, we get 25.38. Remember to put a degree symbol since this is an angle. Okay, we could do the same thing with these next set of problems. Circle your reference angle, label your sides. This is my adjacent, hypotenuse, adjacent, hypotenuse. And we're going to set it up the same way. Cosine x equals adjacent over hypotenuse. Cosine x equals adjacent over hypotenuse. And then we just put that in our calculator. So we're going to put the inverse. So inverse cosine, 5/9. And inverse cosine, 20/38. $56.25. And then 20/38, 58.24. And then lastly, reference angle, label, opposite, adjacent, opposite, adjacent. These are both going to be tan. So tan x equals 9/2. And then put those in our calculator. So inverse tan, 5/12, we get 22.62. And then for the second one, inverse tan, 9/2, 77.47. And again, we're using inverse tan for those. So now that we know that, we should be able to go back to the previous slide, and we should be able to solve for x here. So now that we know that we're solving for the angle, we know that we're just going to be using inverse tangent, 6.93/8. So inverse tan, 6.93/8 gives me an angle of 40.90 degrees. Okay. So now let's kind of apply and put everything together and learn how to solve for the whole triangle. So when I say for the whole triangle, we're solving for all the missing sides and all the missing angles. Well, remember there's a few things that we can remember. To solve for missing sides, we've learned that we can use trig, meaning sine, cosine, tangent. We also know that we can use Pythagorean theorem. Another way we could use it is we could use special right triangles, although that's only in special cases. All right, that's if it's a 30, 60, 90, or a 45, 45, 90. Oops. So those are the ways that we've learned to solve for sides. And then we know how we can solve for angles. We just learned that we can use inverse trig. But also remember that we did learn triangle sum theorem to solve for missing sides. Or sorry, missing angles, excuse me. So what we're going to do is we're going to use a combination of these to solve for all the missing parts. So looking at example 1, in terms of what's missing, I see that we have one side missing, which is side AC, and we have two angles. Angle A is missing, and angle B is missing. So we're going to solve for the measure of angle A and the measure of angle B. Okay, where I like to start with the one thing that we're missing. So since we're only missing one side, I like to start with that. So then we need to look, okay, how can we solve for missing sides? So I'm not going to be able to use trig because in order to use trig, you do need an angle, and the only angle we have is 90. So which means we're probably going to use Pythagorean theorem since it's clearly not a special right triangle. Okay, so using Pythagorean theorem, 19 squared plus x squared is equal to 31 squared. So 19 squared is 361. 31 squared, 961. And then we're going to subtract 361. So x squared is equal to 600. And then to get x by itself, we're going to take the square root. So square root of 600, 24.49. So now we have AC. Okay, next thing we're going to do is we're going to solve for either one of these angles. So here's my suggestion. I would only use the given information because if this was incorrect and we tried to use this number in our calculations for A or B, there's a good chance that we can get these wrong if this is wrong, okay? So what I'm going to do is I'm going to go ahead and use trig to solve for an angle because we can't use triangle sum theorem because we only have one angle. Okay, so using the given information, this is opposite, this is hypotenuse. So OH tells me I'm going to use sine. And since we're solving for an angle, we know that we're going to use the inverse. So it's going to be inverse sine 19 over 31. We get 37.80. And remember, it is degrees. Okay, from here you have a couple options. If you're confident that this is correct, you can either use triangle sum theorem because we would have two angles, or you can use trig again. So because I'm going to go with what I said, use only the given information. So now we're solving for B. The hypotenuse stays the hypotenuse, but this is now my adjacent side. So to solve for B, I'm going to use cosine. So inverse cosine, 19 over 31, we get 52.20 degrees. What we could do is we can just double check using triangle sum theorem that that's correct. Since we know there's 180 degrees in a triangle and we know that this is 90, should be able to add these together. And it should equal 180, which it does. So that's how you can check to make sure you're correct. So now I've solved for all the missing parts and we're done. All right, so let's look at another example. We're solving for all the missing parts. However, in this example, we're given different information. We're only missing one angle, so we need to solve for the measure of angle y. Oops, I don't know why I wrote 7. So the measure of angle y, I don't know why I keep writing 7. The measure of angle y. See, I almost did it again. Measure of angle y, and then the two sides we're missing is zy and xy. All right, so I like to start with the one angle that we're missing. So this one, the easiest thing to do for this, well, the only thing you can do is triangle sum theorem. Since in order to use inverse trig, you need two sides. So 44 plus 90 That's going to be 134. And then we're going to do 180 minus 134. So let me just check my math. 134, 180 minus 134 is 46 degrees. The measure of angle y is 46 degrees. All right, now we can solve for either one of these. So zy is this one. I'm going to call that side A. So I'm going to use this as my reference angle. This is my opposite. This is my adjacent. So to solve for A, I'm going to use tan. So tan of your reference angle equals the opposite over the adjacent. And then we're going to cross multiply. So A times 1 is A, and then we're going to do 10 times tan of 44. You get 9.66. Okay, and then lastly, to solve for xy, which I'll go ahead and call B, that's my hypotenuse. So now we're solving for this side, and we have the 10. So that's A and H, we're going to use cosine. So cosine 44 is equal to 10 over B, and then cross multiply. So we have B times cosine of 44 is equal to 10. Divide by cosine 44. So 10 divided by cosine of 44, we get 13.90. Okay, from here, if you wanted, we can check our answers. We can check using Pythagorean theorem. We know that a squared plus b squared should equal c squared. So if we do 10 squared plus, let's see, a was 9.66 squared, we get that. And if we square hypotenuse, 13.90 squared, we should get approximately the same thing. Remember, it is going to be a little bit off due to rounding, but this basically shows that we did that correctly. All right, now let's take a look at a couple of the homework problems. All right, so starting with number 2, we are solving for the whole triangle here. So I'm just going to list out what we're missing. So we're missing one side, which is AC, and we're missing two angles, the measure of angle A and the measure of angle B. All right, so I'm going to solve for AC first. Again, we're going to use Pythagorean theorem since we don't have any angles. So it's going to be x squared plus 18 squared is equal to 39 squared. So 18 squared is 324. And then 39 squared is 1521. And we're going to subtract 324. Get 1197 and square root. We get 34.60, which seems reasonable given the side lengths. All right, so now let's solve for the measure of angle A. So I'm going to use that as my reference angle. 18 is opposite, 39 is my hypotenuse. So OH tells me sine 18 over 39. So since we're solving for an angle, we're going to use the inverse. So inverse sine of 18 over 39, you get 27.49. Okay, now let's solve for B. So I'm just going to switch reference angles. So this side now becomes my adjacent side. So AH tells me I'm going to use cosine. So cosine B equals 18 over 39. And then we're going to use the inverse. So inverse cosine 18 over 39, where you get 62.51. And again, you can check to make sure that this angle, and the 90 equal 180. That's how you know you did it right. All right, now let's take a look at example or number 4. So first, let's list out what we're missing. We're only missing one angle, so that's the measure of angle A. And then we're missing two sides. We're missing AC and AB. All right, so I'm going to solve for the missing angle first, and we're going to use triangle sum theorem for that since we have two angles. So it's going to be 90 plus 40, which is 130, and then we're going to subtract that from 180. 180 minus 130 is 50 degrees. So the measure of angle A is 50 degrees. All right, now we're going to solve for AC, which I'll go ahead and call X. So using 40 as my reference angle, this is opposite and this is adjacent. OA means we're going to use tan. So X over 11, and we're going to cross multiply. So X times 1 is X, and then we have 11 times tan of 40. Get 9.23. All right, and lastly, we're going to solve for AB, which I'll call Y. That's my hypotenuse. So we're solving for the hypotenuse. We're going to use our given information adjacent. That means I'm going to use cosine. So it's going to be 11 over Y. And again, cross multiply. So we have Y times cosine of 40 equals 11 times 1, which is 11. And divide both sides by cosine 40. Get 14.36. And then we're done. Oops. All right. Last one here, problem number 6. We're solving for a missing angle. This is going to be a multi-step problem. So remember, for these ones, we want to solve for the shared side first, which I'll call y. We are going to have to use Pythagorean theorem for this one since we're not given any angles. So it's going to be 4 squared plus y squared is equal to 11 squared. So 16 plus y squared is equal to 121. Subtract 16. So I have y squared equals 105. And then we're going to square root both sides. So square root of 105 is approximately 10.25. All right, so now I have my shared side. Now what we can do is we can use inverse trig. Here's my reference angle. This is the opposite, adjacent. We're going to use tan. And we're going to use inverse tan. So inverse tan, 10.25 over 8. Going to be 52.03. And it is degrees since it is an angle.